Okay, 2A. When a certain grocery store opens, it has 50 pounds of bananas on a display table. Okay, so that's an amount. So we have an amount of 50 pounds. We don't care if it's bananas or gravel or whatever, water, just an amount, 50 pounds. And that's when the store opens, so I'd probably put something like A of 0 is equal to 50. And I can't use the symbol A unless I tell the grader what it means, so I write A of T equals pounds of bananas. So I have 50 pounds of bananas. Customers remove bananas from the display table. Read slow and careful. Remove at a rate modeled by F. So F is the out rate. So F is my outgoing rate, rate at which bananas leave. Where F is measured in pounds per hour, that makes sense because the amount is in pounds, so the rate would have to be in pounds per some time, so pounds per hour. T is the number of hours after the store opens, so this makes sense, times 0, we have 50 pounds. After the store has been open for 3 hours, store employees add bananas to the table at this rate. So G of T is the rate of increase of the bananas, so that's my in rate. Measured in pounds per hour, and T is the number of hours after the store opens. Part A, how many pounds of bananas are removed? Okay, if we're paying attention to pounds of bananas removed, we don't care how many are there. We don't care how fast they're being added. All we care about is how fast they're being removed. How many pounds of bananas are removed from the display table during the first 2 hours? So the basic idea is if they were removing bananas at a rate of, say, 25 pounds per hour, and I continued to do that for 2 hours, then I would know that I would have removed a total of 50 pounds. We use that same idea, it's just that the rate isn't a constant value, the rate is changing. So that's why we're going to do an integral. We're going to integrate the rate at which bananas are being removed, and just like we did here, by taking the rate at which bananas are removed and multiplying by time, we get how many bananas are removed. So here's my rate at which bananas are removed. I'm multiplying by time. That's going to give me the total amount of bananas removed from the time the store opens, which is time 0, to time 2. So this is what I need to do to calculate how many bananas are removed during the first 2 hours. So here's the official work. 1 point for the correct integral, 1 point if you type it in correctly on your calculator. This is just basically, this is a version of the fundamental theorem. If you integrate the rate at which bananas are being removed from the table, you are going to calculate the amount of bananas removed for whatever time period you specify. So the only thing you needed to do is write the integral for 1 point, compute the integral for the second point, 2 total points.